Okay, this is the Math 3 Unit 4 practice test. Starting with number 1, given the rational function f of x equals -5 over x plus 7 minus 2, state any vertical and horizontal asymptotes. So our asymptotes are found based off of our translations. So I want to look at my horizontal and my vertical translations. I don't need to worry about my reflection at all. So if I have x plus 7, that means I go which direction by 7? Left 7. And if I take my function and subtract 2 from the end, that means I go which direction by 2? Down 2. Okay, this should give me my horizontal and vertical asymptotes. So if I'm going to the left by 7, am I going to hit an x value or a y value on my coordinate plane if I start from 0, 0 and go left by 7? An x value. So that's going to give me my vertical asymptote, which means I write down x is equal to, left 7 is -7. So that's my vertical asymptote. It goes straight up and down. My horizontal asymptote had to go down 2, so that goes through a y value, which means my y is equal to -2. So remember, left and right is your x value because your x-axis goes left and right. Up and down is your y value because your y-axis goes up and down. Does that make sense? All right. Questions about number 1? Okay, number 2. Simplify. Anytime I'm going to simplify, I will factor my numerator and denominator and then reduce my factors. So starting with my numerator, I have a greatest common factor of 7. And that leaves me with 4 minus x. You can write this in standard form first, and it might help you so that when you factor your difference of squares that they match perfectly. But my denominator is a difference of squares. So x times x is x squared. Positive 4 times -4 gives me -16. And then I also know my middle terms are 4x and -4x, which cancel out to 0, which is good because I don't have a middle term on this problem. So let's see what matches. So nothing currently matches, but I do have a 4 minus x and an x minus 4. But I want a positive x and a -4. So if I factor out a -1 from this numerator, what would that make the 7? A -7. And if I factor out a negative, that's going to change every sign that I have. So I have -7. Now I have a positive x and a -4. And then my denominator is x plus 4 and x minus 4. So the x minus 4 over x minus 4 equals 1, which means I'm left with -7 over x plus 4. Taking a look at the numerator one more time, if I would have rewrote that as -7x plus 28, I could have factored out the -7 right away. And then that would have left my binomial as x minus 4. That might have been more simple. All right, so -7 over x plus 4 is that solution, or that simplified expression, not solution. All right, number 3. in order to simplify, I need to factor. So we're going to factor the numerator. We're going to do the short method. So we're going to guess and check this one. X times x is x squared. I need two numbers that multiply to 40 and add to 13. 8 and 5. Very good. Positive 8 times positive 5 is positive 40. 8x plus 5x is 13x. My denominator, we're going to do the same thing. Guess and check. X times x is x squared. I need two numbers that multiply to negative 35 and add to negative 2x. Negative 7, positive 5. We can check that by doing negative 7x plus 5x is negative 2x. So we want to check that middle term. We can also check that negative 7 times positive 5 is negative 35. Good. So those are both right. So now we can start to reduce. So any factor over itself equals 1. So x plus 5 over x plus 5 equals 1. And that just leaves me with x plus 8 over x minus 7. But this problem asks for your excluded values. So if at any point you're asked for your excluded values, you want to list what they are. And those are the x values that would make your denominator equal to 0. So what number would I plug in for x in my final solution that would make it equal to 0? 7. Is that the only excluded value? No, because I put a comma, right? We want to check our factored form. So what other number can I plug in for x that would make my denominator equal 0? Negative 5. So positive 7 minus 7 is 0, and negative 5 plus 5 is 0. Questions? All right, now we are getting into multiplying and dividing. So with multiplying fractions, you just multiply straight across. I'm going to put any of my polynomials in parentheses. And once I multiply, you're going to notice I put all of my monomials out front, which doesn't look different for my numerator. But for my denominator, I'm going to put the x squared out in front because it's a monomial. And you're just used to seeing them written that way, so that's why we write it that way. You can put it at the end, and it doesn't change the value, but this helps you know what to reduce. Okay, when you're simplifying, you're going to do your operation first, and then simplify. And the only way to simplify is to factor everything and see what factors reduce. So, let's factor this trinomial in my numerator. Most of your trinomials on your test will have an a value of 1, but there is one problem that doesn't have an a value of 1. How do you need to factor if you don't have an a value of 1? Good. Factor by grouping. But this one does have an a value of 1, meaning in front of the x squared, that's a 1. So we don't need to factor by grouping, we can just factor by guess and check. So x times x is x squared. What multiplies to 5 and adds to 6? 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. Okay, this binomial is a difference of squares. What does it factor to?
X times 5 plus 5.
Very good. Oh, I wrote plus twice. Please do not write down that x squared minus 25 factors to x plus 25 times x minus 25. That is not how we do difference of squares. Our last two numbers have to multiply to the negative 25. Some of you are just copying the 25 to each one. All right, so x plus 5 over x plus 5 equals 1. So those reduce. Does anything else reduce? The x's. So x cubed over x squared equals 3x. 3x cubed. I'm going to take these two x's that are in the denominator and subtract them from the 3 in the numerator. So that leaves 1 left over. So 3x. I still have an x plus 1 in my numerator. So the x squared reduced, the x plus 5 reduced, so I'm just left with x minus 5 in my denominator. My excluded values, how many do I have on this problem? 3. 1, 2, 3. So in my factored form, if I set each of these equal to 0, I could solve. On the first one, I take the square root. Square root of 0 is just 0. On the second one, I'm going to subtract 5. And I get x equals negative 5. And on the third one, I'm going to add. So I get x equals positive 5. So 0, negative 5, and positive 5 cannot be your x values. Otherwise, it would make your denominator equal to 0. And if your denominator is 0, then your expression is undefined. All right. Number 5. Division. What should I do? Good. Keep the first fraction and then multiply by the reciprocal of your second fraction. Okay, multiplying straight across gives us 84x to the 4th, y to the 4th, over 504 x, y to the 5th. Now, do you have a calculator on your test? No. So if you don't know that 504 is divisible by 84, then it would take you a while to simplify that. So what you could do instead of multiplying the 7 times the 12 together is show that those are going to be multiplied together, but we're just going to keep them separated, but still show the multiplication operation. Same with the 24 and the 21. So if I decided let's not multiply those together, let's just multiply them and set them next to each other, I still have factors. Factors are things that you can divide out. What is this numerator divisible by? Give me at least one number this numerator is divisible by. If I do 7 times 12, that means 84 is divisible by 7 and 12, right? So if I reduce by 7, I'm going to divide by 7 out of my numerator. Divide by 7, I get 1, which means I need to divide my denominator by 7. Which number are you going to divide by 7? 21. All right. Over here, if I divide by 12, are these numbers both divisible by 12? Yes, 12 divided by 12 is 1. 24 divided by 12 is 2. Okay, so for my coefficients, 1 times 1 is? Not a trick question. 1. 2 times 3 is? 6. So 1 over 6. Let me check that. 84 times 6. That gives me 24. 48 plus 2 is 50. 504. So 84 times 6 gives me 504, which means if I divide both of these by 84, I'll get 1 over 6, just like I got here. So you can always check it if you're not sure. Or you can just divide 84 and 504 by the same numbers until you get as small as you can. What about my x's? Where do I have more x's at? On top, so the numerator. How many more in the numerator than in the denominator? 3 more. What about my y's? 1 more y in the denominator than I have in the numerator. So that would just mean I'm subtracting these 4 there. And this one, I'm subtracting from here. So my final answer is x cubed over 6y. Questions? All right, go ahead and flip to the other side. Number 6, another division problem. So we're going to multiply by the reciprocal. And then we can multiply straight across. All of my polynomials I'm going to put inside parentheses. All 4 of these are polynomials. So I'm going to show that these are being multiplied together. How many factors should I end up with in my numerator? 4. How many factors should I end up with in my denominator? 4. So a difference of squares factors to 2 binomials, x plus 2 and x minus 2, for x squared minus 4. For x squared minus 9, that's x plus 3 times x minus 3. But trinomials factor to 2 binomials as well. So let's guess and check for my first set. X times x gives me x squared. What multiplies to 9 and adds to 6? 3 and 3. Positive 3 and positive 3. Okay, for my second one, what multiplies to 4 and adds to 4? 2 and 2. So I get x plus 2 times x plus 2. Let's check those. 3x plus 3x is 6x. That's good. 2x plus 2x is 4x. All right. X plus 3 over x plus 3 reduces. X plus 2 over x plus 2 reduces. Can I factor out negatives from my numerator? No. So I saw some shaking of the head. But if I factored, some people try to do that because they see that these kind of match, but they're opposite numbers. If I try to factor out a negative from x minus 2, what does x minus 2 factor to? Negative x plus 2. So that would still not match positive x plus 2. So I wouldn't want to do that. Which means this can't be simplified anymore, so we need to write our simplified form of all of my factors that are left, which is x minus 2 times x minus 3 over x plus 3 times x plus 2. And you can write those, multiplication is commutative, so you can write those in the opposite order, and that's fine too. Number 7. Adding and subtracting. So the rest of this page is adding and subtracting. How do you add and subtract fractions? Common denominator. Are these denominators the same? No. What can I multiply this fraction by so that my denominator would match the other one? Negative 1. So let's distribute a negative 1 to each of these values. We haven't changed our first fraction yet, but if I distribute that negative 1 to my denominator, I get negative 7 plus x. and then multiplying my numerator by negative 1, I would get negative 2. Are my denominators the same now? Yes. Even though they're not written in the same order, this would be the same as rewriting x minus 7. And then I have a positive x and a negative 7, so that's x minus 7 as well. Which means you can combine your numerators to 3x, what? Minus 2 over x minus 7. Whenever you get common denominators, you want to keep that common denominator in your answer. Don't try to subtract or add the x's together and add the 7's together. All right. If you need to stop me at any moment, just let me know what questions that you have. Number 8. What will my common denominator be?
20y cubed.
Good, 20y cubed. So I look for the biggest number and I look for the biggest variable. I'm going to multiply the first fraction to get to 20y cubed. Or even just say I need to multiply the first fraction by something to get to 20 because we need to make it bigger. So what am I multiplying by? 4. Let's check that. 4 times 4 is 16. 4 times 5y cubed is 20y cubed. I am going to also multiply the second fraction, but don't forget on a subtraction problem, what do we need to do?
Change the sign.
Change the sign and add the opposite. So instead of subtracting a positive 2, I'm going to add a negative 2. That'll help me when I'm multiplying my numerator and denominator. So what am I multiplying the numerator and denominator by?
Y squared.
Y squared. So I changed it to an addition problem, so I'm going to show that. 20y times y squared is 20y to the third. Now they match, which is good. Negative 2 times y squared is negative 2y squared. And then we're going to combine these together. Let's go ahead and put it into standard form. I have a negative 2y squared and a positive 16. My denominator stays the same. What's my greatest common factor of my numerator? Negative 2. You can pull out a negative 2 or a positive 2 depending on what will help you more. And then I'm left with y squared minus 8. And then my denominator is 20y cubed. If you would like to break up the denominator to show the two different factors it breaks up to, that's fine. Otherwise, you can just tell me if I divide the numerator and denominator by the same number, what am I going to divide by? Negative 2 or positive 2, either way. So if I divide by negative 2, I get 1. And what would my denominator be? Negative 10. If I divide my numerator by positive 2, it would be negative 1 over 10. No matter what, if you have a negative in your numerator and not one in your denominator, your solution should be negative. So I'm going to go ahead and represent this negative out in front. Then I still have 1 over 10. Does y squared minus 8 factor more? No, because it's not a perfect, 8 is not a perfect square, otherwise it would. So I'm going to show a few different ways that you could write this one. You can have the negative 1 up in front of your numerator. You can have the negative in front of your entire fraction. You could have, we talked about this at first, this be a positive 1 and a negative 10 in your denominator. So that would be y squared minus 8 over negative 10y cubed. These are all equivalent expressions. Most of the time, if your solution is going to be negative in your numerator or denominator, you'll see it written out in front of your entire fraction instead of just in the numerator or just in the denominator. You can put your numerator in parentheses to remember that this would be multiplied by a negative all the way through. Questions on either of the three forms that I wrote down there? As long as your equivalence holds, you can have any of these three type of answers. All right. Number 9. Subtract. I have to have common denominators again. How do I make these denominators the same? Multiply them by each other. I can't add to get an equivalent fraction. I can only multiply to get equivalent fractions. So if I multiply my first fraction by the other denominator, then I don't have a common denominator yet until I multiply the second fraction by the first denominator. Then my denominators are the same. X plus 3 times x plus 4 is the same as x plus 3 times x plus 4. Don't forget to, with subtraction, we're going to add the opposite. Okay, so I have 6 times x plus 3 over x plus 3 times x plus 4 plus negative 2 times x plus 4 over x plus 3 times x plus 4. Are your denominators the same? Yes. So you can now add your numerators. But you can only combine like terms. Right now, 6 times x plus 3 is not a like term with negative 2 times x plus 4. So instead of adding them right away, let's go ahead and distribute these so then I do have some like terms. What is 6 times x plus 3?
6x plus 18.
Good. What's negative 2 times x plus 4?
Negative 2x minus 8.
Good. Now my denominators are still the same, but now I have like terms in my numerators. These are not like terms because the term they're being multiplied by doesn't match. 6x and negative 2x are both being multiplied by an x, so those are like terms. What is 6x plus negative 2x?
4x.
And what is 18 plus negative 8? In other words, what's 18 minus 8? 10. Okay, at this point, you need to check to see if we can simplify more. How do we simplify? Greatest common factor, which is 2, and I'm left with 2x plus 5, because if I were to distribute, I get to 4x plus 10. Do any factors match in my numerator and denominator? No. So you actually cannot simplify this one more, but you wouldn't be able to tell that unless you factored it. Because if by some chance this factored to 2 times x plus 3 or 2 times x plus 4, then I would be able to simplify. So my final answer can be either of these two. Normally we leave it as the first one that we had, but you can write either of them down. So this is also a correct solution. All right, number 10. What is my common denominator, least common denominator? 15x cubed, which means this one can stay exactly the same. We're only multiplying the second fraction to get there. So what do I need to multiply 5 by to get to 15? 3, and then x squared, because x times x squared is x cubed. What do I do now? Good. Multiply the numerator as well. So this is equal to 2 over 15x cubed plus, good, 9x squared over 15x cubed. Once my denominators are the same, I add my numerators. Let's go ahead and put it in standard form. Which of these terms is going to go first? 9x squared plus 2 over 15x cubed. Can I combine the 9 and the 2? Nope, they're not like terms. Can I factor the numerator? Nope, not a difference of squares. I can't reduce any x values because I don't have one in every single term. I can't reduce by 3 because I don't have one in every single term. So that is actually my most simplified version of this expression. Let's talk about excluded values. At any point throughout your solving process, if your denominator equals 0 for that x value, then that x value cannot be used. So, starting with our very beginning, what number would I plug in to make 5x equal to 0? 0. I could show that by dividing the 5 to the other side and I get x equals 0. What about 15x cubed? 0. 0 cubed is 0. 0 times 15 is 0. So, at any point throughout this, I either have 5x or 15x cubed, so I only have one excluded value. X cannot be equal to 0. Can x be equal to 5? Yeah. 5 cubed is going to give you 125 times 15 is a big number. 5 times 5 is 25. Can x be equal to negative 5? Yes, 5 times negative 5 is negative 25, not 0, correct? All right, go ahead and flip to the other side. All right, we have 5 more minutes, so we're going to go ahead and do number 12 first, and before we do number 11. And then number 11 will be on the next part of the video. Okay, so if I have two fractions here, or if I have a fraction within a fraction, my numerator is considered all one operation. So I have to do 3 over 2 plus 1 over x together, and I have to do my denominator together as well, because all of my numerator over all of my denominator. What does this line in between them mean? Division. So I'm going to take my numerator and divide by my denominator. Now, if you just wanted to simplify your numerator and put it over your denominator first, that's completely fine. We're going to simplify our numerator right here. How do you add fractions? Common denominator. So the first fraction I'm going to multiply by, and the second fraction I'm going to multiply by 2. So that gives me 3x over 2x plus 2 over 2x. Let's find a common denominator on the right-hand side as well so that I can write an entire equivalent statement here. What am I going to multiply my first fraction by on the right-hand side? X. And my second fraction? 5. So that gives me 4x over 5x plus what? Good. Now, inside each set of parentheses, do my denominators match?
Yeah.
Yes. Okay, so let's add the numerators. This gives me 3x plus 2 over 2x. And this one on the right-hand side is?
4x plus 10 over 5x.
Good. 4x plus 10 over 5x. What goes in the middle of these? Division. So all I did was simplify. This is my numerator. I simplified my numerator. And my denominator. I simplified my denominator. Now, what am I going to change my division to? Multiplication. And my second fraction? Reciprocal. So 5x over 4x plus 10. Remember, my binomials I always put in parentheses. So this gives me 5x times 3x plus 2 over 2x times 4x plus 10. Any one of those that I can factor more? 4x plus 10. What are you going to bring out of the 4x plus 10? A 2. So when I bring out the 2, it has to be multiplied by this 2 out here. So this would be 4x times 2x plus 10. You'll see if that you multiply this denominator together and multiply this denominator together. Oh, they should match, but they don't because I didn't do it right. 2x plus what? 5. Very good. Now if I multiply those together both ways, I'll get 20x. What's the only thing that reduces here? X and x. 4 is not divisible by 5. 5 is not divisible by 4. X over x is 1. 3x plus 2 doesn't match 2x plus 5. So this answer would be 5 over 3x plus 2 over, 5 times 3x plus 2 over 4 times 2x plus 5. Questions on that? Please make sure you realize this is x to the first and x to the first. So the x is reduced, the numbers do not. All right.